Good morning, OHS iPad Initiative students. This is Mr. Lane again for section 4.4, triangle congruence, which is over side, 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 and side, angle, side. Remember in the last lesson we had 6 different parts of the triangle that we had to show congruent in order to show that the triangles themselves were congruent. Well, in this it's going to shorten it up a little bit, and we're going to have 2 different ways then to show that triangles are congruent without having to show all 6 things. So as always, make sure you get the title in your notes. Make sure you answer number 5 in your notes also, and you can read through the rest of that stuff on your own. Make sure you pay attention for today's secret word, which will come later in this section. Alright, the first little thing we have is the shortcuts for proving triangles congruent we call triangle rigidity. So triangle rigidity is just shortcuts for proving triangles congruent. And here's the first one. It's called side, side, side postulate. And basically it says if each side of one triangle is congruent to the corresponding sides of another triangle, then the triangles are congruent. So all we need is 3 sides that are congruent to use side, side, side postulate. Notice in the diagram here that the little tick marks here just means that those 2 sides are congruent. The 2 tick marks would mean that these 2 sides are congruent, and the 3 tick marks means that these sides are congruent. Now notice in our congruence statement, I don't know if I've pointed this out before, but when we have a triangle congruence statement, then notice that the vertices H and S here would match up. Those would be corresponding vertices. Notice that how HO is congruent with SU. Well, the HO is in the same location as the SU is right here on the triangle congruence statement. Alright, so something I don't know if I've pointed out before, but there it is. Let's move on to the next page, and I think we should have our first example. It says use side, side, side to explain why triangle ABC is congruent to triangle CDA. So it looks like we need a couple of things here. Let's go A right here, let's go C right here, and then this would be D, and let's call this B. And now I think we got a correct diagram to work with here. So we're given then by the diagram that CD, or segment CD, would be congruent to segment BC. And we're also given in the diagram that segment AD would be congruent to AB. So that's both given to us in the diagram. So what we're missing is this one side that the 2 triangles share, so that we'd have all 3 sides congruent, and we could just use side, side, side to say that the 2 triangles are congruent. Well, what allows us to say that, and we're going to say AC is congruent to AC, well, it looks like it's looking in a mirror. So that's the reflexive property of congruence. Okay, and then once we have all 3 sides congruent, we can say that the 2 triangles are congruent by side, side, side. Alright, so that's what it's looking for in an example like that. Now here's the next shortcut for us. It's side, angle, side postulate, or SAS, but it stands for side, angle, side. Now one important thing is here is what we call the included angle. So if I'm given 2 sides are congruent, then where those 2 sides intersect, forms the included angle. Neither one of these other two angles would work in order to use this postulate. It has to be what we call the included angle. So where the angle in which those two sides that are congruent meet form that included angle. Let's see, if two sides and an angle between them in one triangle are congruent to the corresponding parts in another triangle, then the triangles are congruent. So the included side is formed by the two congruent, the included angle is formed by the two congruent sides. Alright, we got an example to use here. Looks like it's on the same concept as what we just worked just a second ago. Let's call this B, C, this will be D, and this will be A. So let's see what we're given. We're given that segment AB is congruent to segment DB. And that's given to us. We're also given that angle ABC is congruent to angle DBC. So we're given those two things, and it looks like they share this common side again, so we're going to end up using that reflexive property to say that BC is congruent to BC. And again, that's that reflexive property of congruence. And then we can make our triangle statements. ABC is congruent to triangle DBC, and that's by the SAS, or side angle side postulate. By the way, today's secret word is lemonade. Lemonade. First person to send that to me in an email gets 2 points. Good luck. Alright, show that the triangles are congruent for the given value of the variable. Let's see, looks like we're dealing with a little side angle side here, because we're given two sides in the included angle. And it looks like on this we're given that y is supposed to equal 4. So let's mark a few things. ST would have to be congruent with VW by the statement there. So I'm going to mark those two. Maybe I'll change to a little different color so we can tell the markings a little bit better. There we go. TU, Tulsa Gold Hurricane, is equal to WX, this one right here. Alright, so it looks like we have all the values here, so I need to probably plug in that 4 over here. So 4 plus 3 is 7, and notice that 7, it does equal 7, so we'd have that side congruent. Now if I plug in the 4 here for the y, it would be 2 times 4, which is 8, plus 3 is 11, and the side that I have that is marked 11 also. So now if I just have that included angle as 92, I should be good. So let's see, when I plug in that 4 times 20 should be 80, and then add the 12 should be the 92 degrees. So all of them work out where they're congruent, so that's going to allow us to use the side angle side postulate to show that the two triangles are congruent. Alright, I think we have the last example right here. It says show that the triangles are congruent for the given information of the variable. Triangle, let's mark this, well, it's pretty straightforward, it looks like. 7 is the MN, which is going to be the PQ over here. Okay, and then this would be the QR, which would be this right here, and that would have to match up the last sides in being congruent if we're only given 3 sides. Alright, so let's see, the 1 is going to match, well, let's plug in the 5 right here, is going to make 5 plus 2, which is 7. 7 matches up with the 7. When I plug in the 5 right here, I'll get 5. Notice that 5 matches up with the 5. And then when I plug in for the last one here, 3 times 5 is 15 minus 9 should leave me with 6, which matches with this side. So it looks like we got all 3 sides congruent with that variable. So by side, 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 I could write that these 2 triangles were congruent. I think that's going to wrap us up for this section. This was section 4.4 over side, 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 and side, angle, side. This is Mr. Lane signing off. We'll see you next time. Bye.